So, project for the day in the new year of 2024. First project I've started. I have several ongoing projects carrying over from 2023, but this is the first one I'm starting in the new year. So this one is a battery tester. It's my primary battery tester. And if I can get the unit out of its slightly stretchy case, it's the very famous, well-regarded, long-manufactured Pulse-Load Multi-Battery Tester by ZTS. I think they're in Cincinnati. American-made, family company, family-owned company. And they sell these to the military and all sorts of stuff. Been around for years, this model. I think they only have about 4 models of battery testers. And so why is this thing special? Because most battery testers you can buy just check the voltage with a simple meter. And, you know, that tells you maybe if the battery's totally dead or not. But it doesn't tell you where the battery is in terms of how worn out it is. You know, what its remaining capacity is. And even some kinds of batteries, when you test them briefly with a load, will be good, but then a minute later under the same load they drop greatly in their voltage or their just ability to output, you know, any power. So the pulse load tester has a bunch of different voltages and categories of batteries, all with their own contacts, and it applies a calculated load, a resistive load, to the battery for a calculated amount of time for that type and voltage battery. And all the types are listed next to them along with the voltages. You know, 3 volt lithium, 1.2 volt nickel metal hydride, 3.6 volt lithium ion, blah blah blah, you know, alkalines and so on. And so they basically are looking at the battery's performance curves, and the microprocessor in here tailors the operation according to each type. So it doesn't matter, for example, if you have an alkaline cell, AA, AAA, C, D, or N, they're all 1.5 volt nominal, and they're all going to have the same performance curve. The difference between them is that, you know, the bigger ones, like a D cell, has a greater number of watt hours, so it can deliver that amount of current for a longer period of time than a C does, and a C can do it more than a AA, and that can do it more than a AAA, but otherwise they're the same thing and they're going to respond in the same way. So, you know, this thing is battery powered. There's a battery compartment in there, and you just stick the positive end of the battery you're trying to test on there, and then there's a little cable that is stored on the side that you touch to the back side of the cell. So I've got a brand new C cell here. I've got the lead connected up. I'm touching the front to the terminal, and it does its little test and then gives me the report, and it's 100% full. That easy to test, just a couple of seconds for each type. Some types of batteries may actually do subsequent tests, like a brief one, then a breather, then another little test, and then a breather and another little test before it gives you the conclusion of the test. There's also the double terminal things here, like the 9 volt alkaline and some of the button cells and things. So this tester is not the subject of this video. I've kept this thing ever since I've had it in this container up on top of a stack of test equipment in my electronics lab. It's always the wrong place because I don't keep my batteries there, and I hate taking it out of that grippy sack. This would be great if I was throwing it in a toolkit or something. It would protect it. It would be fine. It's made by the manufacturer. It's a good little case. But for my needs, it just makes it more awkward to use. A number of years ago, I designed and built this battery holder and put a YouTube video up. You can watch it if you want on my channel. And this has worked out really well, and this is where I want to generally have this battery tester. It's in my office, not in my lab. But there's no good place to put it in here. Every surface area is busy with something. And I want to have it in something that'll keep it clean, but easier to get at quickly when I want it. So I had the idea of just mounting it to the side of this storage cabinet. That's where I keep my copy machine. If I can zoom out a little bit more. My copy center. You know, just keep it kind of in a holster down here on the side of this cabinet. So it's right there by the batteries, but it's not really in the way. And I can just pull it out and use it anytime I want. So that's sort of the point of this. And I don't want to put screws into this. So I got the idea of doing what I often do, is mount things using neodymium magnets. And I selected a 3/4 inch neodymium magnet. That's about 1/8 of an inch, maybe a little bit less thick. And I did a quick test. I put 4 of them in a row on this cabinet, draped a piece of fishing line over them, and tied that around this thing, along with a paperback book, which is, I thought, you know, a thick paperback book like a Clancy novel. Probably weighs about as much as the holster I'm going to make. And just slung it over there to see if the magnets had enough grip and friction that they wouldn't slide down the side, and they didn't. But I only have 4 of these, and I really want to have security to have maybe 6 magnets. So I ordered a new pack of these things on Amazon, and while I'm waiting for those to arrive, I'm going to get busy making the holster. Alright, I've made up my usual pencil sketch of dimensions. I'm going to use this theoretically 1/4 inch craft plywood, which isn't really 1/4 inch, it's more like 7/32 inch thick. I think it's actually metric, 6 millimeters or something. So 7/32 of an inch. I'm working in inches on this. So the back panel and the front panel are going to be identical. They all have side rabbets as well as bottom rabbets, which I haven't shown here. The side panels will set into the rabbets there, and they themselves do not have side rabbets, in spite of the stupid way I drew it here, because that was an earlier thought I had how I was going to do it. It's just going to be a simple end on both edges, but the bottom will still be rabbeted. That just simplifies the work a little bit. The pieces are fairly thin, and I can't put any hardware into them, so I need to have at least a rabbet joint for more mechanical strength. So I got to get busy and cut some pieces out. Okay, that's my sides roughed out, well, in one dimension anyway. Now I've got to cut them down to 7 and 15/32. Now the sides have been roughed out. All they need is the rabbet cuts. Okay, got the sides roughed out, got the front and back roughed out, verify they're the same height. Now I got to cut the bottom. Okay, now I'm going to make my rabbet cuts using the table saw because I don't really feel like setting up the router for this. So I've got the fence set and I've got the blade raised up just enough for the depth of a half thickness of the plywood. And on this piece I have to cut on the back side. Now that I've got the more important, I think it's going to be a lot out of focus. Now that I've got the more important cuts, then I can just trim away at the excess with a few more passes. Alright, I'm just checking the basic fit of the pieces here, see if the rabbets are done correctly. Everything fits together like it should pretty much. And then the really important thing, does the tester fit inside of it? Yep, just like I wanted it to. Alright, there's the box from the bottom, and I need to adjust the side a little bit here. There we go. And you can see the rabbeted side. I went a little too deep on this. I'm glad I started with the back side. That won't show because I went a little too deep with this last rabbet cut on that one as I was dialing things in. And there's the bottom fitting in nice. And again, I've got the rabbet cuts on the front and rear, but not on the sides. The only rivet cuts on the sides are the ones along the bottom, so the bottom can fit in and recess in there. So these neodymium magnets, these are the ones I already had. The ones I'm going to be receiving are 1/8 of an inch thick. And to make sure they don't pull through the wood, my plan is, here's the thickness of the plywood, to have use a Forstner bit to cut a recess in the plywood and glue the neodymium magnet in there, but that could pull out. These are pretty strong magnets, and the amount of grip that some epoxy or super glue would have on here is pretty good, but maybe not enough to reliably keep these in here. If I pull it away from the metallic surface it's attached to. So the technique I want to use for that is to actually then countersink this and put a fender washer in there, which the magnet will be glued to and also adhered to just by its magnetism, and then it will be impossible essentially for it to pull out. I figure that the attraction of the magnet to the fender washer should be at least as much as its attraction to the metallic surface that the plywood is up against. So that's the strongest thing I can think of. Question is there actually enough depth in the plywood to do this? So this plywood here is not even 1/4 of an inch thick. But the remaining thickness is at least the thickness of the magnet. Okay, so it is thick enough. Of course, this magnet isn't quite 1/8 of an inch thick either, is it? But it's close enough. This 1/4 inch or nearly 1/4 inch plywood is thick enough to do this without being backed up. As for strength, it will have the wood strength of 1/8 of an inch, so half of the thickness of the plywood, which I think will be strong enough. Okay, I'm using these larger, slightly smaller diameter, slightly thicker neodymiums that I had already, and the ones I did my strength test, which I mentioned earlier. And I was going to replace these with the ones I bought on Amazon, which are slightly bigger in diameter but slightly thinner. But when I did a test just putting them on top of my table saw, these old ones seem to have a substantially greater grip, so I'm going to be using these primarily, and I have put in the holes for them, got them to the right depth so the magnets just slightly protrude, maybe like 1 or 2 thicknesses of paper out of the holes. And I still have places for 4 more holes. I put pilot holes in for the larger magnets in case I need them. The holes will already be there. Okay, got all the holes in the back side of the wood. And now I have to put the holes in the inner side. That'll be it's facing the front, but it's also the inner side of the holster, and that'll be for the fender washers. back are my other magnets. Stuck to the back of this. Alright, so there's the back panel with the neodymiums just stuck in there. I found it to be a lot harder than I expected to get accurate depth on these things. So sometimes the magnets stick up into the holes further. This one was just a screw up on my part. I went way too deep, kind of was stepping over something on the floor and accidentally leaned on the lever to the drill press and almost went all the way through. And then I lost 3 out of the 4 original neodymium magnets I had. They were sitting right on my bench. Can't find them anywhere. I'm sure I'll find them years from now, all stuck together up underneath something and stuck to some other piece of metal. But after an hour of searching for them, I can't find them. So I used my Dremel tool to just open up the holes for all the other ones and use some more of the new magnets. I'm going to use all 8 of them in this case because they're weaker. But because of the uneven depth, I want to stabilize these in here. And I'm contemplating just using a little CA glue on that and accelerant, and then later on filling the holes with epoxy and putting in these fender washers for the actual strength. That's probably going to be easier than doing it with epoxy, but I think epoxy might still be the best way to go. I can just, you know, fill it in with all the gaps, go around here, stabilize it, then stick the wash. Just make sure I don't get any epoxy up above the top of the magnets. That'll be the trick. I think that's probably going to be the best way to do it. Well, I decided to use epoxy, and I just sort of dragged it around with the cutoff end of the Q-tip, just the stem of the Q-tip, until it filled the any gaps there were between the magnets and the holes they're sitting in. And then I used the swab part of the cotton swabs to make sure there was no epoxy to speak of sitting on top of the discs or any higher than that, so it would not prevent the fender washers from sitting down flat on the magnets later on. Alright, I've got the washers glued in. I put epoxy on top of the magnets, filled any empty space around underneath the washer, put the washers in, and then filled them up to the level as much as I could with excess epoxy. So hopefully when I sand it, it'll make a fairly smooth surface. There may be some irregularities, but I tried to get it up to a nice lake on top of each one. Okay, the next morning, these are all rock hard now, ready for sanding. Plenty of magnets, that should grip pretty good. Alright, I've got one thick coat of the Rust-Oleum protective enamel, which I just happen to have on hand. I wanted to be able to cover up those magnets, so I didn't use a clear varnish. I have to paint the inside surfaces because with only 1.25 inches depth to the inside of the box, I don't think I'll be able to get inside to paint it later unless I just pour paint into it, slosh it around, and let it drip out. So I've masked the glue areas on the sides and the bottom, and then just painted up to the rabbet joints on the front and rear panels. Okay, 2 coats of paint later. I've got a nice finish on there, and the glue areas are not painted. Got a nice smooth finish. Can't really see where the magnets are on this one. Unless I tip it up, then you can see very slight bulges in the surface where I didn't get it absolutely flat, but otherwise I think that worked out pretty well. I need to get a couple areas where some paint slopped over into, well, actually this part's going to get trimmed off, so I don't even need to do that. See, I don't think I need to really do any remedial work on this. I can just get together with gluing the whole thing up now. Just to have to put the back on, that's the front there. If I had the thing rotated the other way, then the magnets would be sticking to the tabletop. Alright, all clamped up. I'd had some small misalignments on the top just due to setting the fence differently and so on during different cuts on the table saw, and I knew that was the case because I've already made it a little oversized, so I'm going to have to cut that top off. Once everything's glued up, it'll come down about an extra 1/4 of an inch. Alright, I have a little bit of glue in there. I'm going to see if I can come up with some way to smear a little glue along the seams just to make it look a little better. The magnets are on there, the box is trimmed and sanded, so it's coming along well. Okay, I've put a first coat on the edge because that's one of the few really exposed end-grained pieces, and I have gone down with my makeshift brush and filled the corners. So once that dries, then I can put first of 2 coats on the outside. And the first coat on the outside after a light sanding, I found a couple of tiny gaps along the seams in a couple of places, and I decided to fill those with a little epoxy, and after that sets up, then I'll sand those areas and give it a second coat of paint. Alright, since I did the epoxy to clean up a few of the joints, I have put on another coat of paint, sanded it lightly, and put on another coat of paint. The problem is I ran out of the cheap bristle brushes I was using, which I usually get a pretty good finish from, and I was resorting to a foam brush, which isn't the greatest for putting on thick epoxy, or not epoxy, but enamel like this. It's a bit too viscous for the sponge type brush. I usually have good luck with sponge brushes on varnish, but not so much on paint, but that's what I had. So I think the finish is going to be a little streaky in terms of texture, because this paint kind of sets up very quickly, and if you get a run or something and have to go over it with the brush, it leaves a mark that doesn't level out very well. But it's a uniform color. I think for my needs it's going to look plenty good enough. And a couple of times I've sat this down on my table saw, and it's grabbed on there good, but not so much that I can't stick my hand inside the holster and pull it away from the table saw without breaking the holster or pulling a magnet out. So I think that's got a good balance as well. I'm just going to let this do a nice overnight curing in front of my heater fan, and then try it out tomorrow. Alright, there it is. Came out pretty good. I don't have any paint on that side because I don't want anything between the magnets and the metal cabinet. And I get up here into my office, and there are the other 3 original neodymium magnets that I had that I was looking all over for and had to adapt my design because I couldn't find them. There they are. I thought, I'll just leave them there. I won't forget where they are. Alright, there it is. in place. If I drop it down really hard, it goes down about 1/8 of an inch on the cabinet. So it is fairly easily repositionable. Takes a bit of dragging, but I can drag it around pretty easy with a bit of force. But it definitely holds the weight. Excellent.